Hey everybody, we're choosing a sample size. So this is the second part of module 22.1. So it's part 2. So let's go ahead and get started. Here's our question. How can we calculate the confidence interval? That was in the last lesson. And the margin of error, that's for this lesson. And the population proportions of population means and stuff. So we're going to do that. So if you're hearing music in the background, that's because I'm at home and my good-looking wife and I are having a date tonight, so she's getting ready. So you're hearing sort of music. I got the door closed. I'm upstairs. So anyway, sorry about that, you guys. The only time I can fit this in before class starts. So choosing the sample size, you guys. So in section F of the last section, we did this lesson right here. We found a 99% confidence interval to be between, for the population mean to be between 541 and 679. Okay, and so and they ranged from the values of our sample mean of 610. So that was all given here. We calculated all of that in the last lesson right there. Okay, and then so what we can use with that is we can write the confidence interval. This stuff right here, this 2.576 came from our z-score of a 99%, and this was our sample standard deviation right here, not our sample, our population standard deviation, and this was our sample size right here. Okay, so when we found that out, we found this little piece out to be 69, about 69. It was 69 and some change, and so this also was 69, and so we took our sample mean, which was x bar, and did 610 plus or minus that 69. And that 69 is called our margin of error, and I'm going to abbreviate it in this lesson as MOE for margin of error. So the margin of error is always half the length of whatever the confidence interval is right here, okay? So this was, this confidence interval is, what's that, 138, so if we take half of that, that's going to be 69 right there, okay? So we're going to use that information to create sample sizes. So the margin of error for the proportion of successes in a population. Now this is just this stuff right here. Here comes my new dog Lucy. She opened up the door. Let's shut the door again. Hi Lucy Lou, come here honey. We found her in front of my classroom a couple of months ago, a little baby puppy, and so she's become our sweet little dog. Anyway, sorry. Where was I? So let's see if I can get going here. Sorry, Lucy interrupted me here. So anyway, so the margin of error. Oh, I'm sorry. I know what I was thinking. So the margin of error is this stuff right here. This right here. It's this z-score plus or minus this right here. And if we're doing a population proportion, then it was the z-score that went for the population proportion. You remember that formula from our confidence interval for proportions right there? So that's our margin of error, okay? And P is our sample proportion, which I didn't put a P hat on there. Let me put a P hat on there. This should say P hat. So sorry about that. Sorry, let me get that in there. So P hat is our sample proportion right there. And I just want to make sure I have it ready for my kiddos when they come into class. N is our sample size, and whatever our z-score is, what 95% confidence interval or 90% or 99%, that table that we gave, we talked about in the last lesson right there, okay? So, and if they don't give you P hat, you guys, then assume it's going to be 0.5, okay? So if they don't give it to you, sometimes they don't, but if you assume it's going to be 0.5, then it's going to make our this value the largest, which makes our sample size the largest, which makes it more safe to calculate a confidence interval. Okay, don't worry about that too much. So you'll see more about that later. The margin of error for the mean and normal for the mean, you guys remember the mean was this stuff right here. So the error was just that z-score times the standard deviation divided by the square root of n. Okay, now we're going to be solving for n on both of these right here. So we're going to solve for n on this guy. We're going to solve for n on this guy. Okay, now they're going to give us the sample mean right here, and the population standard deviation, and whatever our confidence interval is right here. Okay, so in each of these formulas, you guys, as the denominator increases, think of a number. Think like 1/2. That equals 0.5. Okay, think of 1 over 20. That's 0.05. If we did 1 over 200, that would be 0.005. So as the denominator gets bigger and bigger and bigger and bigger, then it makes this value get smaller and smaller and smaller and smaller. So as the sample size increases, our margin of error decreases. Okay, so here we go. This researcher wants to know the percent of teenagers in the U.S. who have a social networking profile. She is aiming for a 90% confidence interval, so we got to find our z-score for 90%. I think it's 1.645, I think. And the margin of error is 0.044%. What sample size should she use? Okay, so, all right, so let's see. And she's aiming for what sample size? Okay, so she's doing this right here. So we're going to go ahead and plug this in right here. Okay, and the reason why we're doing the population proportions, which is P, is because she's aiming for the 90%. And so what sample size? So it's all in terms of percent. I don't see anything about numbers with means or anything in there. So we're going to use this formula. I'll do another one just like this. Okay. All right, so here we go. So the margin of error is 4%. Our z-score is 1.645 right there. Okay, they did not give us the p-values, so when they don't give us the p-values, then we assume it's 0.5. So this is 0.5. This is 1 minus 0.5, which is 0.5. Okay, and we're going to solve for n right here. Okay, so what I'm going to first do right here is divide both sides by 1.645. Okay, all right, so here we go. So we get that. And then now we got to get rid of this radical right here. So to get rid of this radical, we're going to square both sides. Okay, so when we square both sides, we get that. And 5 times 5 is 25. So 0.5 times 0.5 is 0.25. Okay, so that's where I got this 0.25 right there. And then I multiply both sides by n right here. So that gets me this guy times n equals this, which is 0.25, and then we're going to take 0.25 and divide it by that. It's going to give us a decimal. And then this is how many people we're going to do. How many people is she going to, what sample size should she do? So the person should survey about, of course, round it to appropriately, and usually you round it up to 423 teenagers, okay? All right, sometimes you don't, but all right, so this one is in your textbook on page 1125. Zoe is an editor of a newspaper in a state capital and wants to know the percent of residents in her state who are in favor of banning the use of cell phones while they're driving. And these are handheld cell phones. I just took that out to save some spacing in my text right here. While driving, so a bill that is being considered in the state legislature. So after researching similar polls conducted in other states, she estimates, okay, here's our p hat. This time they give us p hat, so we're going to do p hat 1 minus p hat. Okay, she's aiming for a 95% confidence interval and a margin of error of about 5%. What sample size should Zoe use? Okay, so we're going to use this formula right here. And 95% is the 1.96, so that goes here. And margin of error of 5%, that's going to go here. So 0.05, and then 0.35 goes here. 1 minus 0.35 is 0.65. That's what goes inside of there. So let's divide both sides by 1.96, and I went ahead and multiplied these two guys together to get that. Okay, now we got to get rid of this radical, so we're going to now square both sides. So when we square both sides, we get that. Then we multiply both sides by n. Okay, so when we multiply by n, we get that, and then divide, and we get about 350. And then always go back and answer these word problems in the context of the problem. So what sample size should Zoe use? So Zoe should survey a random sample of about 350 state residents at least. So if she did more, it's just going to decrease the margin of error. So the lower the margin of error, the better. So anyway, so at least 350 right there. Okay. All right, let's do one more here. So Caleb is a restaurant manager, and this is example 3B on page 1124. Restaurant manager who wants to know the mean number of seconds it takes to complete a customer's order. He is aiming at a 95% confidence interval, so that's the 1.96, and a margin of error of 6 seconds. Okay, that's the E. So based on past experience, he estimates the population standard deviation to be about 21 seconds. So what sample size should he use? Okay, so this one's going to be this one where they give us the standard deviation right here. Okay, so we're going to go ahead and plug in the 6 seconds right here, the 1.96 right here. This is 21, and we're solving for the sample size, the n right there. Okay, all right, I'm going to divide both sides by 1.96, and then square both sides because we got to still have a radical. We've got to get rid of that n inside the radical, so we got to square both sides. So square 221 or 21 is 441, and then square the square root of n, and we get n. And so we get that. So we're going to cross multiply, and we get this right there. And then we're going to take that up there and divide, and we get about 47. And then, so what sample size should Zoe use? Remember, these are random samples. Or it's Zoe? Caleb, sorry. So Caleb should survey a random sample of 47 orders to answer his questions. All right, you guys, if you are in my class, you're going to be taking care of that. Take care.